The flow of the session I'm imagining here is we're going to go through, how to authenticate as a user when you want to consume the data. We're in this webinar, we're positioning ourselves, as a consumer, not a deployer of Diffuse, the open source solution. So we're going to go through quickly authentication and how do you call the REST APIs, what sort of semantics there are there. We'll try the WebSocket API and the GraphQL endpoint. And if you have any question whatsoever during the session, please do not hesitate to interrupt me and ask, or punch it in the chat and someone else will interrupt me if you're too shy, whatever. Okay, so I have most of the things I'm going to talk about. Sorry, I'm going to share my screen here. Most of the things I'm going to talk about are decipherable somehow in our documentation. Okay, it's possible to go in the docs and reference for EOSIO, and the REST endpoints there are listed. The WebSocket API and its methods are in there, and the GraphQL API has a rendered documentation for all that is query and subscription. So I'm going to touch on the important bits and show, let's say in a more human level, what this all entails. It starts, where does it start? With authentication somewhere. Somewhere we talk about authentication. So let me show you how we'd actually do that. On my machine, I have a little script. You see my screen here? Yeah, I assume yes.
Yeah.
You see, I have a small script that will curl the auth endpoint, authentication diffuse user, and issue. The goal is to issue a JWT, a JWT, which is in, a signed little packet that allows you to be authenticated on all of our services. This is particular to the hosted diffuse instance. When you roll out your own diffuse locally, you don't need authentication. You actually don't need to pass the headers we're going to pass, but this is for authentication against our endpoint. And we send the diffuse key, which I have as an environment variable. The key looks like this, server ABCD, whatever. Okay, looks like that. You get that from the API portal. And when I punch the diffuse token, then I will have, a JWT token. This is valid for 24 hours, and it contains the information that authenticates me on these things. So if you're fast enough, you can copy it and use it for 24 hours. And now, let's start with the first request. I jotted down a few requests here. Here you have some nice code from the code base, and here you have my flow for today. Let me try a simple REST call over here. So let's decouple that here. This is adding the authorization header. It's a bearer header. This is standard HTTP stuff. And we're going to connect to the Kylin network. And this is the endpoint for Kylin. And we're going to reach out for the V0 block ID by time endpoint. Let me show you the doc for that. This allows you to query, I call it the spinal cord. It allows you to query with comparators greater than, greater or equal than, less than or equal with a given time. And it says, what's the block number at that point? So very simple, you'll get back the block ID and block number. And if we try it out, well, you get exactly what you expect here. Okay, so you get the block ID for that particular date, but see how, did I put it equal? And I could say here, let's say dot 0232, and we will get the one that is greater or equal to. See, that's the next block, 22. Okay, so that's an example use of, it's very simple. You want to curl stuff, you got it there. And in there you can search transactions, but I'll show you right after that you're better off with the GraphQL, and I'm going to show you why, because of the cursors, but you still can do some sort of paginated searches here. Okay, and a bulk of these are state queries. I'm going to try that one too. Let's say the state. We want to reach for the table states. You guys know about states, I assume. Let's say you go to an account in EOSIO, and there's an account called RAM Market, and you can see that there are columns, right? And this is decoded through the ABI here. We won't go into that here, but you can query all these tables for this scope, and you get the data in. That is what the scope, sorry, the table endpoints are used for. Taking these. All the state is about tables. So if I go and I try to get some state tables. I'm going to decipher that for you guys here. Maybe I haven't done it here, but in that side you've noticed there's the time in the ISO standard way plus the comparator. In here, we're going to ask for state table. That means a single table of state, but you're always able to give that at an exact block num. So I say an exact block. It's rounded at the end of the block. When you query that at block 25 million here, you're asking what was the state of the blockchain when the 25 millionth block was executed, okay? And we're gonna see for the account EOSIO token, the scope B1, now the EOSIO token contract lays out its data in the scope that is the name of the account that holds a balance. And the table is the table accounts. So we're gonna have it in JSON here. It's gonna be decoded on the fly with the ABI that was valid at that block height. So you get a consistent view of that table in the past. And then you can follow through what was it, you know, at block 125 million. See, it changed. And so yeah, at some point it changed. This one gives you slices of data in time. It's the only system around that gives you the blockchain state at any block height. It's a purpose-built database, and it doesn't exist. You don't have, there's no other tool that does that except FluxDB, which is part of diffuse platform. You can also, if you want to go further, like this is just one user, so you can go and grab a list of users. You can get a bunch of tables by asking tables scopes and listing them. And I'm trying this, I haven't tried it before, so and see in there you can list scopes with an S and pipe them all, right? So you could say scope B1 EOS nation for the when is that the run at block 25 million. What was the state of things there? Oh, see, so bad. What do I need to do? Okay, this is terrible. Did you see my error there? I think I know.
You have
the pipes. Oh man, column 9.
Trying to see if we're following, huh?
It's terrible. What is it? Bad example. Pause the recording there. Anyone sees the error? Scopes. That's probably a bashism, no? Those ampersands and those pipes.
Yeah, I'm not sure.
Scopes. Okay, so let's ignore that. So you would get here a list of those elements, and you'd have the table included there. So you could list multiple tables. Very bad example. I'll get back to you later on. Or is it? Oh, just the URL. That's bad. Stables of. Oh, there you go. I'm so very sorry here.
So when you pipe many, like
error was I forgot
like a
tables
filter or something.
Was tables instead of table. So JQ was the one complaining because it received a 404. What tipped me was the 404 here. So this is an error from JQ. Okay, does that make sense?
Yeah,
Yes.
we have 2 attendees if you want to promote them to panelists.
Oh, of course,
Alex.
of course. Give me a second here.
And Sylvain, did that answer? Because I think you were about to ask a question.
Yeah, there's when you pipe many accounts like that, is that a filter or what does that mean? I'm not catching.
Yeah, when you pipe the multiple accounts, it'll just return all those accounts. So if you want to go like search this account or that or this or that, it'll just return all the results.
Okay, good, thanks.
Yeah, and you can also like
crashed here.
search with notifiers. So sometimes like an account is not. Let's say if you want to search accounts that were notified, and sometimes they're not like to or from, but they're just notified. The pipe also works with that as well.
So in this one, we're talking about
state, yeah,
state tables. I think you're talking about some of the WebSocket stream we're going to see after.
Yeah.
This is a little different. But we've reused that pipe, which is an implicit or separator. Could have been commas. We chose pipe. And this is in the REST and WebSocket. The GraphQL has its own semantics. We're going to see.
One of the big use cases, I just want to mention that one of the big use case for the snap or like the state is like for taking a snapshot. You say, okay, I'm going to do a token snapshot at block 25 million. You can really, well, you can accurately find, okay, give me all the token balances of everyone at this block number. And like Alex was mentioning, this is the only database purposed for this. There's no other solution that you can get per block number state balances. So this is really great for making accurate snapshots of a token supply.
Actually, it's the only way.
It is the only way
to reliably do that sort of remotely, right? So you have a network running and you want to, the other option is to freeze or create snapshots, but then you're in the race to send the command to the right place if you wanted to have a given point in time or before an action was given on the chain. So, and this, you know, because the chain moves so fast, the example I will always give, and probably I gave that in the previous ones, is that when you query node EOS, you can query 1,000 rows and then 1,000 rows and 1,000 rows. But if you go over a boundary of block there, it's possible this has changed or this has changed when you pass already. So it's nearly impossible for large tables to get a consistent view. And you don't want to have $1 million here, have it transferred there and double account it, right? It doesn't make sense. You want a clear, consistent snapshot. So FluxDB and these endpoints give you that. And it gives you first a list of scopes. That's another feature that this system gives that you cannot query the blockchain to have. What are all the scopes that exist at one point in time? And then you can even select the ones you need or you want. Otherwise, you need to query for, I'm thinking for accounts, balances. They're all in different scopes. So really, that's a priceless tool to have. Okay, if you have any questions, don't hesitate, dump that in the chat. I'm going to continue here, share my screen. So this is for the REST API. There's a few other functionalities we have in there to get a transaction by ID. And this provides you with a lifecycle object. The lifecycle actually is very interesting. I would say it's less of it was extremely useful in the days where deferred transactions were all the rage, right? They're less all the rage today, but this brought you a very nice view of all the life cycle of a transaction, even considering its deferredness, right? Because you have here the created by, the information that who created this deferred transaction, and you would get the transaction itself before it's being actually executed. And then when it's executed, you would get the trace of execution, plus the reference where that transaction was actually, created. And that, it's like if you say scheduled true, I think you can find all these transactions. Let's say this one here. See, you see this one was created by a smart contract and it was created by that transaction in block whatever. And you see that information shown graphically here, that it's created a deferred transaction for 0 second and its execution is separate. This transaction ID, A3, whatever, created C8F and it's executed later. And the status of deferred transaction can also, be canceled. They can be, they can expire and all sorts of different statuses, okay? And in there you get a complete view of that transaction. There's no other system that gives you a more complete view stitching deferred transaction. And they still exist, right? And people still use them. So that's a good thing. And you get that with just the endpoint I showed you, slash transactions here with the ID. Does that make sense? This one here goes over and will decode content that is normally packed, hex row like that. And it's going to decode it at a given block height. So similar to the functionality you get when you get the tables, but you can do that with, whatever content, or in this case, it's going to use the ABI for the account and it's going to decode to JSON. So it's merely using the decoding system as a remote and using the ABI at a given block height. Does that make sense for people? Okay, interject if there's anything. The push transaction is a very different feature. That's a drop-in replacement for pushing transactions. And the goal here is, so as you guys might know, when you're sending a transaction to the network, you're actually sending it to an edge node. The edge node is not a producer node. The producer nodes are behind firewalls, whatever. But when you send that to the edge node, which is just a random node connected to the network, we call it edge, it's not special, it's just somewhere near you, right? And you're sending it, it's going to be executed right away. It's going to give you the trace of execution. It's going to tell you it worked or didn't work. And here's the side effects. Here are the 75 other calls that it did, and it'll give you that information. But it's not true in the sense that it's not what's going to make it into the chain. That transaction, when it passes the first node, is then forwarded to the next, which executes, forwarded to the next, until it reaches the block producer node. And when the block producer node executes, only that execution trace becomes true because it's ordered and put in a determined way in a block that makes it to the consensus. It reaches all the nodes. So that's the real execution. So what we do with the push transaction guarantee thing is that you can ask to receive the response only when the transaction is in a block. So that means you're going to push a transaction. Yes, it's going to go through the first node, second node, block production. And then when the block arrives to our infrastructure and it's executed, you're still listening to see what's the real result of that transaction. And then you will get the actual real traces of execution. And at that point, you are sure your transaction made it into a block. Yes, it's going to take 500 milliseconds more, but you get a level of guarantee that you can communicate to your users. And then you have different other levels of guarantees. This, when you hand off, it means the first producer handed off its rounds to the next producer. So there's less and less chances of forks. Irreversible makes it so you're sure there's going to be no more forks because it's irreversible according to the protocol. Okay, so that's an interesting feature. A feature in and of itself. People use that feature in isolation with the rest. We also pass through to things. Now let me go, if you can always interrupt me, let me go to the WebSocket. Okay, the WebSocket API is this is the first one we shipped, right? First thing we wanted when we did all the diffuse thing is craft a WebSocket. Now I know Hyperion just released a WebSocket version similar to what we had a year and a half ago. And we sort of deprecated that one because we really feel that the GraphQL subscription system, at least for get action traces, is unparalleled. You're better off going with the GraphQL subscription than starting today with get action traces. So I'm going to demo the get table rows, which is a feature that is not fully, let's say, comparable in the GraphQL equivalent. So it's still worthy to have it here like that. Get info just merely sends you head if you want to keep tabs of where the network is at. But get table rows will stream you a snapshot of a table plus follow through with any changes that will occur to that table when transaction mutate that table. So it's like imagine in MySQL, you say select star from table, and then you also continue listening on that table. If there are rows that change, poof, they're sent to you, right? So it's really a remote synchronization protocol for a table that's on the chain you're listening on, and you will also get everything you need to be able to sustain disconnection and come back and continue where you left off. So really you can have in your own JavaScript memory, whatever, a clone of what's in the blockchain, react to change, and then do constant processing on that table, aggregation, whatever, but you're in sync with the blockchain, which is pretty cool. And to do that, we connect with, I have a small tool here called WS, it's a command line tool, and you pass in the token not in a header here, but as the parameter token. If you won't get access. And then once you're connected with a valid token, then you're going to issue some commands like this. Get table rows the type. So we've crafted our own sort of protocol for synchronization here. That's why GraphQL is better. It has defined all these things that are more, I'd say, widely known. This is a pattern with a request ID, and the request response will have the same request ID, right? And the function is table rows. What we want to fetch, we want to get a snapshot. We want to fetch a snapshot of the whole thing before we start listening. And we want that in between the snapshot and the listening, we're guaranteed there's no gap. We're not going to miss a beat. Do I have that here? Never miss a beat. That's the guarantee of the work we've done so that the snapshot is immediately tied blockwise to the next streaming. And this system supports undoing your rows. Actually, it's transparent. So if you listen to the stream and you merely apply the change, you will always be in sync, even through forks. Because when there's a fork, you will be sent the reverse operations that occurred plus the new operation that make it so that you're at the end in a consistent way. Does that make sense? So if we do that, we're querying here the EOSIO, the global table, which normally changes each block. It's part of the onBlock action, which is implicit on each block. And we want to fetch the snapshot on the first run, then listen all these changes. So let's see how that goes. So I don't know if you see the pace at which it goes. Tack, 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 right? It comes each second. I don't know, we'll have to review that. And let's see the first one you normally get is table snapshot, then listening, then table delta, right? So for a given primary key, you would just go and override the primary key here of global and you apply it, yet you start with a full snapshot of the table. That could be 250 megs. It could be, 1 kilobyte, just like it is here, but you're gonna get a snapshot. Like the voters table of EOSIO is really huge and it can go to 250 megs, but it doesn't matter. It's gonna stream it out, consistent, and then start streaming changes. And that's controlled with fetch or listen. Okay, does that make sense? Isn't that cool?
Yep.
Oh, that's me hitting enter. The command is not right. That's why there was an error. If I hit enter, well, it sends a faulty JSON input. Okay, do we have any questions?
Yeah, we still have about 15 minutes to go. So if you have any questions, feel free to stop Alex.
So we have promote to panelist and Mark. So everyone who joined, they were going through the usage. If you have any question, please dump them in the chat. Please interrupt me. I'm trying to break the webinar style because I like the interactivity there.
So I guess the WebSocket thing makes it really easy to make a dynamic block explorer that shows what's happening as it happens on chain, for example.
Right. You still want to be precise. This is a table. You have streaming actions. It's not a fire hose, right? If you're looking for a fire hose, you'll get a huge pipe because the things go very fast in there. It's able to do that, but you need to filter by a certain contract, right?
Yeah, for sure.
Transactions and tables also. Right. But yes,
But I was
of course, no, block explorers are just, in our opinion, and that's why we built EOSQ, is just to merely use the APIs. The real power is the APIs, the data systems that make that work. And block explorers are shim, right? Just a UI on top of that. The hard part is not the graphical aspect, although we want to make it, consumable and all that. The hard part is the backend, and we always strive to make the backends developer friendly. So it's easy to build block explorers, and I don't know if you've seen, there was that guy, EOS, does that still work? EOS Inbox? This one. Oh man, he shut it down, maybe. Oh, so anyway, the guy built a block explorer using, it looked like Google's inbox, right? But it was all diffuse queries behind, and he laid out things, and you could explore the blockchain using something very similar with, tags and whatnot. But it was just behind the scenes diffuse queries. And it was very interesting. I think he shut it down. Maybe he didn't want to pay for hosting his app. Okay, I'm going to continue here. Do we have any other questions? I want to go into the GraphQL side of things. So WebSocket, simple. You have a request. You have those fetch and listen. Most of the endpoints have that pattern of fetch and listen, but most of the time you'll listen, and that's it. Okay, let's go into GraphQL.
Just real quick, there's a question in the chat from.
Go ahead.
He asks, the beauty of this is that one can open the API through GraphQL. Quick question, do you guys support auth? I imagine you meant auth 0?
So I went through authentication just a little early. So is that someone, Daniel? He wasn't there when I talked about. Let me just recap there. I have a small diffuse token here. Authentication on the diffuse hosted version. This is the company, us. You can authenticate and grab a JOT from this here. So if I diffuse token, then I get, and I export that variable, I get a token that I then pass back when I connect here, either in WebSocket or in curl, you know, I pass as an authorization bearer token. That's how authentication from our standpoint occurs. When you're running diffuse EOS on your local command line, when you have it locally, you're using a null authentication plugin, because this is pluggable systems in diffuse EOS and diffuse for EOSIO. And in that case, you could craft whatever you want for authentication. You would roll your own, you know, systems to grant tokens and do authentication in your service. Does that answer the question, Daniel? Was it related to that? It did. Okay, perfect. You're a panelist. It's good. Let me continue now with GQL. No, not GQL. So when you say GQL, you're talking about GraphQL. In any case, GraphQL has the same authentication. You're going to pass the authorization header, and it's the same system that we use, which use our authentication plugin that's connected to, you know, the portal where you go and create keys and all these things. Okay, you can easily. This is a very small plugin that that you guys can write or you can help out. Now, GraphQL. Let me share my screen again. GraphQL here. Let me show you. So the fun thing with the GraphQL is that the query is embodied in the request. So you can easily copy and paste graphical, it's called. We have one instance of that for all the networks. And you go there and it's using a key that is rate limited, but you can use try it out, right? This a key is not your own key. And all these things you can do through the command line, either with curl, like subscription require a WebSocket. This is the Apollo protocol. We also support GraphQL over gRPC when you want to do GraphQL queries, you know, from Python or whatever, because GraphQL itself is agnostic to the protocol. That's why you will see GraphQL requests always return 200, because it doesn't care about the wrapping protocol. It only cares about the payload inside. So you'll get, even if you have an error, a 200. Just be aware of that. So this here is crafting a subscription. Maybe I can take a few minutes just to, because I think it's maybe lesser known, GraphQL, although it's very easy to discover, especially because you get all this typed information. Like inside GraphQL, you have rendered documentation that is directly output from source code, not from source code, but this is a DSL, right? That tells you, let me see here. Whoa. It's a schema that is declared that the server negotiates. It's very well bolted in, and then you can use that as tooling to, you know, render what you want here, block and whatnot, and all the fields under block. So the tooling around that is amazing. That's why discovery is so easy. Now what we're going to do here is we're going to, a second, close that. We're going to run a query like this, and the query is, we want to see any action that targets the EOSIO token. That's an action transfer where the quantity is not that amount. You've seen that amount sometime, right? Yeah. And then we're going to list 10 of those. And if I hit enter here, now just to, yeah, okay. This should have started faster. The demo gods are against us. So we've limited to 10, and this is the information we're getting. So because we have a search query, we're listing only the actions that matched the search query. It's also possible to get all the top level actions, right, that are encompassed in there, and maybe all the actions, executed actions. And that's related to the transaction at hand, right? We could list all of these and see, we would have one top level action. There's a bunch of executed actions that are done down the road, but those who matched are only these, because you want it to be specific. So you can go and craft really the payload, the return payload that you need, and get perhaps only the data you want. Maybe you don't want to have the receiver or the sequence number. So that's going to shrink your payload and keep only what you want. And then I can make that unlimited. And if I do that, it's going to stream forever. Now that's probably going to give a lot of things. So sometimes the UI freezes because there's too much data coming through. It's a UI problem, not the backend problem. Backend can ship gigabytes very fast. So, and 47, so we're skipping blocks here because the thing is jammed. So let me try another request here, like the on block, like receiver EOSIO action on block. I know this one comes one after the other, right? The on block is on each block. See, one per block, tack, 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 tack. and you get all the JSON payload there. So, and this is not going to stop. It's never going to stop. And you'll notice that little thing here, the cursor. Can I grab it? And if you interrupt the flow and you give it back the cursor, oops, comma here, it will continue from that point exactly. Okay, I'm going to start again. If I restart again, see the block number 409. Oh, see 409? It starts with 409, then streams all the rest in one swift. So it goes pretty fast. So with the cursor, this cursor is aware. You guys probably know that, right? This cursor contains the block ID. It contains the exact position of the transaction inside the block. So when you come back, it knows if it has to undo anything, if you were left in a fork, or if you were left on the canonical chain, and it's able to give, you know, all the undo signals, which maybe you haven't looked there, but there's an undo signal here. It says undo. If there was a fork or reorganization, you would get those transactions back again and would say undo true. So you can go in your systems and rectify, because this is an eventually consistent database, right? Eventual consistency we have here. You could always select here for irreversible only if you want, irreversible only true here. And in that case, you would only stream, is that the correct thing? Oh, wait a second, that's in search forward. Irreversible only here, right? Like that. And in that case, you would only get things that are irreversible, but delayed, right? So it's a trade-off between speed and certainty of irreversibility. Oops. And
Alex, I'm just going to just jump in real quick. Trying to make sure we're aware of everyone's time. About 5 minutes.
Yes.
There you go. Thank you.
Jump in real quick. Yeah, you want to?
No, he was just saying that there was only 5 minutes. Well, now 3 minutes left.
Okay. So that's the search subscription. There's a few other methods also in the GraphQL, but none are as powerful as this one. This is the history, and this across disconnection. I think that's one thing that distinguishes the diffuse platform from all the other solutions out there, is that even though your system gets disconnected, and during that disconnection time, there's some reorganization or whatever, if you come back, you're guaranteed not to miss a beat. Whereas with other solution, if you connect, you're disconnected for a moment, and during that time, there's reorganizations, and you connect back, you've lost the information necessary to make sure you have a reliable view of the chain. Maybe you're still going to keep that $1 million transaction, and it's better, I think, that's why we designed it this way. It's better to use a system that gives you those guarantees, because when you integrate that, you integrate it once, right? So you choose the protocol that gives you those guarantees, and this cursor is the thing that allows you to have that guarantee, because it contains more information. The backend systems are able to renavigate. Even in the past, right? You could be disconnected for a week. Like I'm assuming sometimes, and now I want to just qualify that. The system is designed so you can come back after a week, and then you would undo the little segment that you were left on, so you're absolutely sure you're still in canonical chain. We try to give a certain level of, because if we reprocess data and we lose fork information for some reason, we give a guarantee of 24, 48 hours for that. But, if you run that system on your own, you could give yourself a larger window and say, my systems always want to be able to be disconnected. Let's say a parking lot thing wants to update its config once a week. Well, maybe it's left on a fork. It doesn't really matter. It's going to come back in a week and then just sync to have in its memory the latest table from the chain. But so you want it to have something reliable. Okay, that's a little.
Alex, correct me if I'm wrong, but with the diffuse for EOS stack that they can download, which is open source, there is the GraphQL interface, as well as the block explorer in there, right? Yeah.
You punch in, if you diffuse EOS start, we've shown that last week, right? If you use EOS start, poof, you have the Explorer, you have the GraphQL, you have all the WebSocket, all the bells and whistles that we have in there. They're available right on your laptop, and then it can scale up to large networks like mainnet and then other networks. And when you need professionally run services, you can come to us. So look, I encourage you to go to that repo, diffuse-EOSIO, star that. That's going to be good for you, good for us. And it shows your support. And it'll give you, maybe if you want to watch and get notifications when we get new releases and all these things, because the thing is moving quite fast. There's a lot of new features coming out, like global filtering for those there we're working on, so that you can have a reduced version of a network, so you can run it eventually locally for even large network, just selecting what you need. And yeah, it's gonna be helpful for everyone. Any other questions? Let's pop up the discussion here. I mean,
I had a question there, Alex. In your GraphQL, you had a alpha get tokens section.
yes.
Is there any sort of a beta or fully feature complete token, like get token endpoint at one point, or is it still a customizable?
So we're talking about this one, right? Tokens. Yep. This will give you a list of tokens, the number of holders, the total supply. This is a piece that actually works. Token balances for a given account with those options. And this will give you, oh, there's an error, maybe the amount there. Quantity, I don't know. It's been a while since I looked at that. And this gives you for that particular contract, oh shit, it's gonna be a lot of information. I think it's gonna give you all the token balances for all the users.
Okay.
No, what is that? It's paginated. Oh yeah, end cursor. So it gives you all these and it can be sorted. And so it's a view of tokens. Yes, it's a specialized indexer just to give you a view of all the tokens. You can list tokens, sort them, and this is all in memory. It's very fast. I don't think this is open source yet, though, because it's still in alpha. We wanted to make sure that we could get out the bulk, and we'll see how that one goes. But yeah, it was marked alpha because we just started it. It's matured. We'll see about that. Does that answer the question? You're curious, right?
Yeah, and I'm assuming that if you had an account, a single account name, and you want to list all the token balances.
Yes, that's the flip side. Get account balances.
Yeah, okay, that's good. Yeah, that would be really, I think that would be a good feature.
Yeah, we made that when I think EOS Park shut down. They have that feature. People asked for that. So we have that specialized token API accessible there. We haven't advertised that much, it's true. But it's there and it works and people use it.
Perfect.
Right. Any other questions?
So I'm looking forward on installing. I tried already, but I couldn't get the documentation for installing my own version of diffuse. So how much support is there going to be, and what's kind of your business model behind that and all? Because I don't know if it's open source, but do you have a comprehensive documentation on how to set it up, or?
So we've open sourced recently, and the documentation on how to set it up is still being worked on. There's a few issues and some docs, MD docs, like the multiple phase to synchronize large networks, because it's sometimes a challenge to synchronize large networks. Like people, independently of diffuse, have a hard time doing that. We hope to make it easier, and we've designed things to separate the problems, but separate the problem of execution and indexing and all these things. So things are pretty clear cut, and they also enable massively parallelized operations, which is something it's very difficult to do when you're doing sort of state history API sort of thing, because the way data is laid out. But to answer your question, you asked business model, or
well, I looked for a comprehensive install and I couldn't really find one. And I was compiling, I was getting some errors, which I thought were on it's kind of your ballpark to indicate how to proceed. Yeah, so how do you have a
source? It's pretty well documented, and you'll have dependencies. Like there's node things that need to be built if you want to build radically from source. So you need to yarn install, but these are documented. There's a separate document for that. But now the thing that is less documented is how to deploy large scale infrastructure. Because what you like to install it is very simple. Download the binary, run it, and that's it. You're started, right? With the Node EOS.
Yeah, I couldn't even get there. So for the next phase, I'll look then. I know it's different according to each use case, probably. It's not everybody's going to set things up after that. But just to get it running, if I get an error message.
That should be very, take a latest release, run it on your local machine with Node.js with the right version in the right place.
Yeah.
And it's going to start. You're going to have the Explorer boots, the things coming in, and we're going to improve that a lot by booting a chain for you. So inserting the boot sequence. And we're working on migration tools also to take data from one chain and inject it in the new chain. So you start off with some data that previously you had before.
Okay, so I guess there might have been some updates. I'll try again. Maybe I'll just pull again and try again. Yeah,
like the team is working like crazy on these things, and it's actually the pace of innovation on diffuse for EOSIO has increased a lot recently.
Right, I don't doubt it. Yeah, I've seen it. Yeah, for sure.
We'll do another release also. There's a bunch of new things that came in I don't know, this week and next week.
Yeah, and for us, we're doing compiles on the develop branch because the master branch is not late enough.
Right.
The developer, you're building develop. Yeah. Any other question related to this session or something like that? Okay. Thank you all for your presence here today. That was good. We'll see you around.
Thanks a lot.
Thanks, guys. Cheers.
Hey, bye-bye.